Okay, so our last topic is about the estimation methods. So what we're going to learn here is how to find the formulas for estimating our unknown parameters. So what do you mean by estimation methods? Finding the formulas for estimating the unknown parameters. So we're going to learn how to find that the sum of xi is an estimator for mu, and we're going also to find how the sum of xi minus x bar squared is over n minus 1 is an estimator for sigma squared. So this is what we're going to learn here. We're going to find these formulas to estimate the unknown parameters. In order to do this, we need a distribution. The distribution has an unknown parameter or unknown parameters with unknown parameters. And of course, in order to estimate the unknown parameters, we need a sample of size n. Okay, so we have a distribution with unknown parameters and we need a sample of size n. So what are the estimation methods that we're going to study in this course? So the estimation methods in this course are the method of moments estimators and the maximum likelihood estimation. So for each approach, I'm going to teach you the general steps for each approach, and then we're going to apply each method on different distributions. So I will start with the method of moments. The method of moments. So what do you mean by the method of moments estimators or method of moments estimation? So to use this method, you need to know two things. You need to know that there is something called sample moments. Another thing is called the theoretical moments. What do you mean by a sample moment? So when we calculate, or when we have the sum of xi over n, I'm going to call this the first sample moment. Why is it first? Because the power of x is 1. So for the second sample moment, it's going to be the sum of xi squared over n, and it's the second sample moment because the power of x is 2. So what about the theoretical moments? For the theoretical moments, so instead of saying theoretical moment, we could say just a moment. And when I say a moment, I mean a moment around 0. So we have the expected value of x is the first theoretical moment. The first theoretical moment. Why is it first? Because the power of x is 1. And this is a moment around 0 because we're not subtracting anything from x. Expected value of x squared is the second theoretical moment. So this is what we mean by a sample moment and a theoretical moment. So what are we going to do with the sample and the theoretical moments? So steps 1. So count the number of the unknown parameters. 2. According to the number of the unknown parameters, find a system of linear equations in these unknowns. To find this system, equate the sample moment to the theoretical moment. For example, if the number of parameters is 2, so we need 2 equations in the 2 unknown parameters. For solve this system of equations. Oh, by the way, not necessarily a linear system of equations. It is just a system of equations. Okay. A system of simultaneous equations. Okay. Solve this system of equations. And that's it. So let me give you example 1. Let x1 up to xn be a sample of size n from a uniform distribution of 0 and theta. Find the moment estimator for theta. Okay. Solution. 1 unknown parameter theta. So this means 1 equation. So we're going to start with the first theoretical moment, which is the expected value of x. We know that the expected value of the uniform distribution is going to be theta plus 0 over 2. So your expected value is going to be theta over 2. Then this is your first theoretical moment. We need to equate this first theoretical moment to the first sample moment, which is sum of xi over n. So the expected value of x is theta over 2. This is equal to x bar. So this implies that theta is equal to 2x bar. Now theta is standing alone. So once theta is alone, put or add a hat on the top of this theta, and this is the answer for this question. Example 2. We're going to talk about a gamma distribution. So let x1 up to xn be a sample from gamma, alpha, and beta using the method of moments. Find alpha hat and beta hat. So we have two parameters. So this means we need two equations. We're going to start with the expected value of x. Expected value of x is a function in alpha and beta. Then we know that the variance of x, or the variance of the gamma distribution, is alpha beta squared. We also know that the variance of x is equal to expected value of x squared minus the expected value of x all squared. We can say that expected value of x squared is equal to the variance of x plus the expected value of x all squared. So the expected value of x squared is going to be alpha beta squared plus alpha beta, alpha squared beta squared. Now the first equation, expected value of x is equal to alpha beta equals to x bar, sum of xi over n, while expected value of x squared is going to be alpha beta squared plus alpha squared beta squared is going to be sum of xi squared over n. Now I know that every alpha beta is going to be x bar. So I have here alpha beta times beta plus alpha beta squared equals to sum of xi squared over n. So this is going to be, I'm going to replace alpha beta with x bar times beta plus x bar squared sum of xi squared over n. Sorry. Okay, so this means that now I have this equation, and beta is equal to sum of xi squared over n plus, sorry, not plus, minus x bar, okay, divided by x bar. So this is going to be sum of xi squared over n x bar minus 1. So this is your beta. Okay, so this is your beta. Now alpha from the first equation, so let me circle line this. So this means this is your beta. So this is beta hat. What about alpha hat? Okay. Okay, so alpha hat is going to be from, this is equation 1, and here we have equation 2. Alpha hat is going to be, if this is beta, so this means alpha hat is going to be, okay, x bar, I can replace, I can substitute with this one, x bar over x bar times x bar over the sum of xi squared over ni, not ni, sorry, x bar over sum of xi over n minus x bar. So this is going to be x bar squared over the sum of xi squared over n minus x bar. And this is the solution for your alpha and beta. So this is alpha, this is beta, and here we have alpha.